If you think space work is only for lifelong rocket engineers, this story complicates that picture. NASA is saying something more practical. Modern missions need people who can work across systems, tools, teams, and data. That matters now because space programs are getting more complex, and because AI and automation are being folded into engineering workflows, not kept on the side. The source is not announcing a new mission. It is quieter than that. It is a profile of Corey Elmore, a pathways engineering intern at Kennedy Space Center. But the profile points to a bigger question. What kinds of experience now count as useful in space work? NAS as answer here is clear but limited. Service experience, logistics, teaching, and systems thinking matter. If they connect to real engineering processes, that is the payoff for viewers, a clearer picture of how a space institution actually defines useful talent. The article centers on NASA Pathways, a program that places students alongside experienced staff on real projects. In this case, Elmore works in the Technical Processes and Tools branch at Kennedy Space Center. That detail matters. He is not presented as designing rockets alone. He is supporting the engineering environment, technical tools, and processes that help NASA teams design, analyze, and operate complex mission systems. The article also says his work explores how artificial intelligence, machine learning, and automation can improve engineering workflows. Again, the claim is careful. NASA does not say I replaces engineers. It says these tools can help organize information, improve analysis, and support faster decisions as missions generate more data across interconnected systems. So the real story is less about one intern and more about how large technical organizations work. Space systems depend on process, documentation, software, and coordination, not only hardware. The strongest tension in the story is in the title itself, From Service to Space Systems. Before entering STEM, Elmore served in the U.S. Navy as a hospital corpsman supporting Marine Corps and Navy units. He also worked as an instructor with Navy Seabees, training service members in mission-critical skills. NAS's point is that these experiences build habits that transfer. The article names 3 in particular: breaking down complex information, leading under pressure, and making sure other people can perform effectively in demanding settings. Those are not small skills in engineering environments. The piece then traces a second step in the transition into defense and shipbuilding work tied to naval maintenance and logistics systems. That is where the systems link becomes more concrete. The article argues that maintaining ships and preparing spacecraft share a common challenge: integrating disciplines, processes, and technology into one reliable whole is a measured claim, and a plausible one. One useful way to read the article is as a definition of engineering that is broader than many viewers expect. Engineering here is not only equations or hardware design. It is systems thinking. It is understanding how people, processes, and tools interact inside a mission environment. The article keeps returning to that point through mentorship, collaboration, and cross-disciplinary work. It also adds education to the picture. Elmore earned a degree in supply chain and operations management, and is now pursuing computer science studies focused on AI and machine learning. That combination is revealing. Operations, logistics, software, and intelligent tools are being treated as part of the same problem space for a channel focused on China-related questions. That broader lesson matters beyond ASA. Big technical programs often depend on institutions that can blend operations, talent pipelines, and engineering culture. This article gives a small but useful window into how one American institution frames that challenge. It is worth being precise about the limits of the source. This is a NASA profile piece. It is designed to explain one person's journey and present pathways in a positive light, so it does not prove that service backgrounds are a common routine to an ASA, or that AI is transforming engineering outcomes at Kennedy today. It does not provide numbers, performance results, or comparison with other hiring pipelines. What it does provide is narrower and still valuable. It shows the traits NISA chooses to highlight in public service: mentorship, systems thinking, interdisciplinary learning, and practical use of AI tools inside engineering workflows. That is evidence about institutional self-understanding. It also shows how an ASA wants viewers and applicants to think about space work not as a closed world for a single elite profile, but as a system with room for operational experience and technical growth. That is the clearest takeaway from this source.